Despite the presence of normal matter in our universe, there are some natural sources of antimatter. Our sun's core has a temperature of approximately 15 million degrees Celsius, which separates hydrogen atoms into a plasma consisting of protons and electrons. As part of the nuclear process that fuels the sun to generate heat and light, protons can change into neutrons, which also emit positrons, which are the antimatter equivalent of electrons. The positron is quickly annihilated with one of the many surrounding electrons to create gamma radiation. This radiation travels out of the core of the sun, passing through the sun's outer layers. The gamma radiation gets absorbed and re-emitted many times by collisions with electrons, over hundreds of thousands of years before it actually emerges from the sun's surface. At this time, the original gamma radiation energy is reduced so that the emerging radiation is in the visible light spectrum. So daylight is actually a result of matter and antimatter annihilation. Another example of natural sources of antimatter can be found within our own galaxy. There are clouds of positrons, which are antimatter, close to the center of the Milky Way galaxy that we can detect from their gamma ray signatures. However, this is an extraordinary situation that happens around X-ray binary stars. These are normal stars that are being consumed by neutron stars or black holes. Their gases are pulled away and spiral into the consuming entity, causing the gases to heat up, generating pairs of electrons and positrons. There are more examples of antimatter generation as well, including the natural decay of radioactive substances such as certain uranium isotopes, which happens right here on Earth. Human beings are also able to produce antimatter in small quantities using particle colliders.